Thanks to a bridge, Valley City was born in 1872. And thanks to Valley City, another bridge was reborn. The Rainbow Arch Bridge in Valley City could have been left to just photographs and memories if it weren't for people who would not let it become just a memory.
But I relate it to the origin of the city.
It's a bridge that's very special to a lot of people.
Bridges are special to Valley City. In fact, it calls itself the City of Bridges. That's because 14 bridges in town help the 7,000 people of Valley City cross the meandering Cheyenne River.
Well, we have a number of bridges in town. I know that most of them are old and beautiful and have history behind them.
Not only are the bridges part of Valley City's beauty and history, but they are vital to the region's transportation. Since early this century, it's been virtually impossible to get across town without crossing at least one of the bridges. The first bridge goes back to before the town was born, back to the 1870s when the Northern Pacific Transcontinental Railroad came through town.
Valley City was the second crossing of the Cheyenne by the Northern Pacific Railroad west of Fargo. That's how we got our first name, second crossing of the Cheyenne. What happens is when there's a river crossing and people start settling, then most towns spring up around the river crossings because everybody has to merge together to cross the river, and that would be a good place to put a town.
As the city grew, so did the traffic across the river. Even though there were no bridges for people, horses, or horseless carriages, the only bridge in the valley was the original railroad bridge, or the low line bridge as it was later called. So a low spot in the river, with easy access up the banks, became one of the first crossings. When it became apparent that it was impractical to ford the river, especially through floods, a wooden bridge was built in 1879. The lifespan of that first wooden bridge was short, just 20 years. So in 1899, a steel bridge crossed the Cheyenne River.
At that time, they were practically mail order. You just, told the factory how long a span you needed, and then they just shipped the parts.
By the early 1890s, the population grew to more than 2,000 people congregating around the bridges in Valley City. The steel bridge was no longer enough to carry traffic. Something better was needed. The Rainbow Arch Bridge that stood here for 80 years was actually the third structure at or near this location. The early wooden bridge and then the steel bridge, both lasting about 20 years, had served their purposes, but by 1920 it was time for another bridge. At about that same time, an engineer from Iowa, James B. Marsh, traveled the Midwest promoting his bridge design. He made successful sales presentations in Kansas, Iowa, and North Dakota. His bridges, Marsh Arch Bridges, were built as far north as Canada and as far south as Florida.
Actually, according to the records, the head of the State Highway Department wanted all in-state designs, but at that period of time there was a lot of towns that wanted bridges built, and they just didn't have the time to design all those different bridges, and so they kind of cheated and bought a design.
The federal government paid half the estimated $35,000. The state and Barnes County split the other half, each paying about 25%, or about $9,000. Marsh's design was to be built on the east end of Valley City's Main Street. It was a patented bridge design with a steel arch embedded in concrete. That's a change from many of the pure structural steel designs of most bridges of the day. The concrete was more than just a decorative feature, it became an integral part of the design. Marsh promoted his bridge in the upper Midwest as one that would expand and contract with the summer's warmth and the winter's cold.
He traveled extensively throughout the Midwest and really touted the bridges as durable and economical and aesthetically pleasing. And North Dakota got 2 of these bridges. One was in Mott, and the second was in Valley City.
Marsh sold his bridge on the abilities to withstand Midwestern weather, promoting its ability to withstand the freeze-thaw cycle that would cause the bridge members to expand and contract. By 1976, though, problems were noticed and a solution was needed. After several decades, the extreme weather conditions began to leave their mark on the bridge. What would it take to keep the bridge? Would the bridge be lost? Since the original Rainbow Arch Bridge was built in 1925, traffic had grown immensely. The old bridge was having trouble with the larger loads. As many as 5,000 vehicles crossed the bridge every day. And not only were there more vehicles crossing the old bridge, they were larger and heavier. The average pickup truck used by farmers today is 25% larger than those of 1925. That made the old bridge a tight fit for today's traffic. Its 2 12-foot driving lanes had no shoulders, so traffic was crowded. It was so crowded that it became a safety hazard. By the middle of the 1960s, the bridge had become a death site. The squeeze from the wider roadway to the narrow bridge was a killer. The old bridge had another size problem, too. It was only about 5 feet above the river's normal level. The Cheyenne River is prone to flooding, and the old bridge had taken its hits in some of the floods. Because it couldn't handle the traffic and the floods, it was deemed functionally obsolete. By 1987, the North Dakota Department of Transportation rated the usability or sufficiency rating of the bridge at 48.5 out of a possible 100. It was time to replace the bridge. Structurally, the bridge was weakening. At every joint where the concrete hangers had to move to accommodate temperature changes, the concrete broke away. The deck had deteriorated some, though it was not in danger of caving in.
It's hard to know what they used for concrete back then, what that was made up of. But you know, surely now our concrete should be as good, if not better, than that. And it's tested, so I would think that we would be able to outlast that one.
The easy fix? Tear out the bridge and put in a newer, stronger, flat, functional structure. But that approach of function over form was not an idea that was universally accepted. So the first job was to build agreement on how to replace the Rainbow Arch Bridge and at the same time protect the environment.
And then another environmental thing, which is a lot more abstract, is the social environment, how people feel about things. That's something you can't quantify, but it sure comes into play emotionally. And we saw that on this project.
I think there were those who really wanted to keep that old bridge because it was their bridge. And there were those who were more concerned about safety on that bridge.
Before a new bridge over the Cheyenne could be built, state and local government officials had to bridge social, historical, and cultural divisions. It was an effort in community relations and building community support. That's something the North Dakota Department of Transportation works hard at maintaining. Community involvement, such as meetings and other communication techniques, keeps people aware of projects in their neighborhoods.
25 years ago, people used to complain about not knowing about a project until a scraper showed up in their front yard.
The North Dakota Department of Transportation helped facilitate a series of meetings to explain the need for a new bridge and find a design that would satisfy most people. At the meetings, 2 thoughts became apparent. One was to build a stronger, safer, modern, streamlined bridge. The other thought, preserve Valley City's history and not lose the landmark.
Initially, those two interests were miles apart. There was a huge chasm between them, philosophically and I think even personally too.
We held several public meetings, and we had great turnout at those. We had over 100 public comments on the project throughout the planning.
That's why the New Jersey engineering firm Liechtenstein Consulting Engineers and the local engineering firm Cattermosley and Jackson were hired to look at other options. They looked at ideas that would include rehabilitate the bridge to meet current traffic and flooding standards, build a parallel bridge alongside making both one-way bridges, pick up the bridge and move it to a new location, or build a new bridge. And the most cost-effective and efficient design was a plain, flat, modern design. The existing bridge could not be widened. Its design did not allow it to be altered to be taller or wider. The bridge could not be moved because it would destroy its historic integrity. In addition, nearby areas where the bridge may have been moved were also protected.
And if we would go north of the existing bridge, it would have impacted a local park, which requires special environmental processing. If we would have went south, we probably would have impacted some historic homes. Again, another significant environmental impact.
It turned out that basically if you wanted to do anything to it, other than replacing the deck, you almost had to destroy it.
So North Dakota DOT engineers set out to design a bridge to meet the desires of those who wanted a safer, stronger, and better bridge, and at the same time satisfy those who wanted to preserve history and the look of the old bridge. So they designed a new Marsh Arch Bridge just like the old one, but better. They adopted 1925 bridge designs to modern-day requirements.
It's interesting to work on something different than just a standard pre-stressed beam conventional bridge. You know, this is out of the ordinary. It hasn't been designed like this for 75 to 80 years, and so it's nice to bring something back and to follow the design of that they used in the original.
In my mind, it was a great compromise because it was a new bridge that was wider and higher in elevation to prevent flooding concerns. And it was also still a Marsh Rainbow Arch Bridge.
The challenge was not just redesigning the bridge to meet new standards, it was also to build the bridge with new techniques. Gone were the 1925 days of cheap labor.
It was just that the way it was built was very labor intensive, and in 1925 labor was cheap. In 2003-04, labor is very expensive. The structure itself, it's a beautiful structure. It's probably a long-lasting structure. But we could have built a regular structure much cheaper. It's just inefficient method of utilizing men and materials.
The North Dakota Department of Transportation then set out to do something that had not been done in nearly a half-century: build a Marsh Arch Bridge. Once the bridge was closed to traffic, equipment moved in to start 7 months of work.
I wasn't quite sure how you demolish something like that, but the contractor had some pretty good people on board, and they decided the sequences, and basically they took out most everything till the arches were the last thing to go.
Without the experience and knowledge of the last crew to build a Rainbow Arch Bridge, a lot of techniques for building the bridge were made up on the spot. Workers' first task was to get rid of the concrete guardrails. They were jackhammered apart. Then reinforcement steel inside was cut. Sections were then lifted out and away from the bridge. Crews then turned their attention to the bridge deck, the driving surface of the old bridge, and the support beams under the deck. Using a hydraulic jackhammer on a backhoe, the bridge deck was removed in large sections during the next few days. The entire demolition took only about 2 weeks. Then came the hangars, like ribs of a giant skeleton. The hangars from the arch dangled, separated from the bridge deck. They were taken down one at a time, leaving only the 2 rainbows, but soon they too would be gone. Once all the railing, deck, floor beams, and hangars were removed, then came the big moment to bring down the arches.
Originally, they thought that once they broke the arches in half, that they would still be suspended, and then they would take each piece out. But when they broke the arch in half, they actually both halves fell in. And so for the first arch, they weren't prepared for that. The second arch, they had tied cables around both sides, so those arches were easier to get out because they had a plan.
Since some pieces fell into the water, they had to be fished out later. It's difficult to build a bridge without disturbing wildlife during the time of year when fish are spawning and waterfowl are nesting. That's part of the reason that once demolition was complete, workers built a wall to separate the river from construction. Sheet piling, interlocking lengths of steel were vibrated into the ground, forming a solid wall. A pump kept the water out, so work could be done inside.
The Game and Fish Department and Fish and Wildlife Service typically limit the contractor from working in a river channel between April 15th and June 1st, and that's because that's the prime fish spawning time frame. And during the design phase, we talked to several contractors about this project just to get their input on what concerns they would have, and that was the main one they had. To allow them to work in the channel, the DOT local government people worked with those agencies to get permission to let the contractor work in the channel, and the condition of that was, like I said, to enclose the abutments before they removed them.
After the sheet pile was driven, a backhoe excavated the dirt inside the newly made cofferdams. The area to be excavated surrounded the existing ends of the bridge and went back into the roadway. That meant some of the old abutment and footings had to be removed to make room for the longer span of the new bridge. The old bridge had been 120 feet long. The new bridge would be 151 feet long. Building the bridge from the bottom up meant putting down a solid foundation. Piling was driven 35 feet below the ground surface to a hard clay level underground. In all, 62 pilings on each end were driven, 124 total. And though hidden from view, they are some of the most important pieces of the bridge.
The support for everything, that's what your footings for your abutments sit on, and then your arch supports sit on your footings, and then your arches are supported by your arch supports, so everything sat on those pilings.
After the pilings were driven, workers formed the footing, tied the 14 tons of reinforcement bars or rebars for the footings, and then poured them about 240 cubic yards of concrete. While work was going on inside the cofferdams, other workers were preparing the support system that would hold the bridge until the arches were in place and the arches could support the bridge. It took 2 weeks to build the support system, or the false work, 12 rows driven into the riverbed in which the temporary workbed was built. Once the contractor was ready to start spanning the river with the new bridge, a key part of the arch had to be built. First, the footings were poured on top of the pile that had been driven into the ground. The base, or the arch supports, then were poured on top of the footings. The concrete pumper truck placed the concrete inside the forms. Then to that, the steel arches were attached before they were encased in concrete.
There's anchor bolts that come out of the arch supports, and then when that arch sits into that arch support, then there were bolts put in, and they were actually attached.
Meanwhile, the steel trusses for the arches had been hauled in. They got to the job site in sections and had to be bolted together in place. While they were still on the ground, workers attached some of the wooden forms to the trusses, which serve as the interior framework of the arches. It's another technique improvised on the spot.
That was probably the most stressful event, I think, because nobody had any way of knowing for sure if the steel would fit. I mean, if anything was off by a half an inch, you would have known.
Crews would finish the forms once they were in place so they could pour the concrete encasing the steel arch frames. At the same time the steel arch trusses were installed, crews also slipped into place the struts between the arches, the ones that would later read 2004. But before they buttoned up the forms to pour the arches, the hangers had to be installed. Each one was 6 inches wide, made of 3/4 inch steel of varying lengths, hanging straight down. The bottom of the hangers were attached to the floor beams which hold the driving surface or the deck. The steel frame had to be in place before they could start wrapping the steel with the concrete, starting with the concrete arches.
The arches and the abutments were poured, and that was a 600 cubic yard pour. And it lasted about 13 and a half hours, 32-man crew.
So they had a long days, a large pour. Everything had to be timed out right because they were pouring on 4 sides. They were pouring, and they could only bring the arches up at a certain rate, so one didn't get ahead of the other. So that was quite a challenge.
Once workers poured the arches and the concrete was allowed to cure to strength, they stripped the forms from the arches. Then they formed the floor beams, wrapping the wood forms around the rebar in them. Even as crews formed up parts of the bridge, such as the floor beams, they also started backfilling around the abutments and pulling out the sheet pile that formed the cofferdams. After the floor beams were formed and poured, then came the next major task, the bridge deck or driving surface.
Deck was 9 inches thick. It was all epoxy coated. All the rebar in the deck and all the rebar in the arches was epoxy coated. So it was more durable, more resistant to rust. If you looked in the removal of the old bridge, there was barely any rebar in anything. This one is so designed that the total rebar in pounds, and I don't have any idea what the old one was, but in looking at what was removed, there wasn't a lot. But the rebar in this new bridge, it was 80,800 pounds of rebar that was not epoxy coated, and then 122,000 pounds that was epoxy coated. And the deck pour was 235 cubic yards, 72,000 pounds of epoxy rebar. So it was a pretty substantial pour, and that took 26 men, 8 hours.
After the deck was poured, crews went back to the steel hangers, wrapping them with wire mesh and building wooden forms around them. Last came the smaller but essential pours, such as the rails, the sidewalks, and the overhead struts. Gone were the 1925 markers, and in their place 2004 markers resting above traffic. Details on the bridge, such as those 2004 markers overhead, received just as much attention as the structural elements.
They had a really good carpenter working for them, and he actually started, when they started removing the bridge in April, he was building forms on an off-site location.
Tony Wickenheiser, project superintendent, was a man charged with figuring out ways to build the 1925 bridge with 2004 techniques, as well as making sure all the details were in place.
Well, all the detail, the handrail is all historical type handrail, all of the detail in the arches. Every board we take off has some kind of a detail under it. There's nothing you put on that when you take it off doesn't have detail on it. It's a challenge, especially when you're pushed for time, you know what I mean?
The new Rainbow Arch Bridge was designed and built by a team of widely talented and skilled people.
2 feet 3 inches. 2 feet. 3 inches.
The project required a network of people, each doing their share to make the project happen. Public officials brought a divided community together in one supportive group. Carpenters off-site, crews on-site, and bridge designers brought up-to-date 80-year-old plans and made a 21st century structure that had as its core a 20th century heart.
1, 2, 3.
The bridge is designed and built to last through the century, which means those new cars that crossed the newly built Rainbow Arch Bridge the day it opened will themselves someday look as antique as the first cars crossing the old Rainbow Arch Bridge in 1925. The new Rainbow Arch Bridge cost under $2.5 million. It's built to outlive the old bridge. It cost $35,000 and stood here for 80 years. And just like the original, this one too has a place in history.
And we can consider it a genuine Marsh Arch Bridge. It's not an imitation, it is the real thing, except that it's higher, it's longer, and it's wider, and it's safer. Everybody is very pleased, very happy with it, and what you see now is, in my estimation, quite beautiful.
Yeah, it is a beautiful structure. I'm too much of an engineer. I'm too much of having everything functional and everything's got to have its place, and it still should. But that's a beautiful structure. Sometimes we have to build a work of art, not necessarily an engineering art.
This work of art puts Valley City, the city of bridges, on the map and in the history books, where it will remain for hopefully another century. While the other Marsh Arch bridges in the United States continue to age and fall apart, this engineering art may end up being the last one standing.